Zivilisation braucht Nahrung.
Civilization needs food, develops medicine, fights illnesses, gains energy. It needs transportation over land, sea, and air. It addresses the problem of waste disposal and strives for quality of life. In order to achieve all this, the human race must constantly separate a wide range of mixtures made up of both solids and liquids. Modern technology uses the physics laws and centrifugal force for this task. Centrifugal force is generated through rotation around an axis. The force generated by the rotation moves outwards. It rises or falls on the circuit depending on the speed of the rotating body. This property makes it useful for mechanical separation technology, for tasks involving separating heavy substances from light substances or separating material with different densities. Centrifugal force acts on all particles. The material, which is specifically heavier, is pushed out more forcefully and quickly than the rest, causing it to deposit on the edge of the vessel. Separation via centrifugal force is quicker, however, if the vessel has an insert. The insert causes the specifically heavier particles to be deposited more quickly, thus helping to reduce the separation time. This leads to a higher throughput, meaning that larger quantities of liquid mixtures can be clarified or separated in the same space of time. The more inserts used, the shorter the separation time and the better the throughput. GEA Westphalia separator has been using these physical principles for over 100 years. Modern high-performance centrifuges are known as separators. With a modern separator, the bowl rotates up to 15,000 times per minute. Through continuous research and development, the centrifuges from GEA Westphalia separator have become a high-tech product, which is now an integral part of everyday life in the modern world. Let's take a look at the separator bowl to better understand the design and the function. Similar to the vessel mentioned above, the area in the bowl is fitted with inserts. Conically arranged discs, however, can be packed more closely together with smaller spaces between. The mixture to be clarified is separated into as many layers as there are discs mounted. Taking the speed into account, a comparable, we refer to it as equivalent, clarifying area can be achieved in a bowl the size of 80 football fields. In order to understand the entire function of a separator, we simply have to follow the path of a liquid loaded with solids through the centrifuge. The mixture to be clarified enters the rotator via a centrally positioned inlet pipe. The distributor speeds up the product and guides it into the separating chamber to the disc stack. This is where the actual separation of the solids and liquids takes place. The discs are arranged according to flow mechanics. The flow properties of the solids is particularly important. Their higher density means that they reach the bottom disc surface and move from there to the solids chamber. All that remains now is to extract the separated liquid, for example, the product to be processed at a later stage, at the top end of the centrifuge. For the extraction process, the liquid rotating in the bowl at an extremely high speed is caught by a centripetal pump inside the centrifuge. The spiral-shaped channels of this centripetal pump take up the speed of the liquid and guide it to the outlet pipe. A high pressure level is created there, which forces the liquid out of the bowl. But a separator can be used not only to clarify liquids with a solid's content, but also to separate liquid mixtures, such as an oil-water mixture, into oil and water components. The inside of the separator has been modified slightly for this purpose. The disc arrangement is also equipped with so-called rising channels. The position of the rising channels depends on the proportions of the liquid phases in the mixture and plays a key role in the efficiency of the separation. Generally, the components which are required in the purest form are given the largest area. The separated phases are removed under pressure by centripetal pumps. If solids are also separated, they can be extracted either manually, for example intermittently, via a periodically opening ejection system, or continuously by nozzles on the bowl periphery, as shown in the example. The separation of liquid substances is just one of the tasks carried out by mechanical separation technology. This takes place with a separator at extremely high speeds. Industry has a completely different use for centrifugal force if a mixture consists of extremely different solids and liquids. A different centrifuge construction is used for this task, the decanter. In many production processes, different substances with completely different liquids and solids proportions have to be processed. In food production with fruit juice and starch, for example, or when facing the major challenges posed by environmental protection. Decanters are used for solids content of up to 60%. They clarify, separate, or drain a wide range of different substances. A horizontal bowl rotates in the decanter, which is equipped with a cylinder and a conical part. A scroll is fitted inside the bowl. The liquid-solid mixture to be clarified enters the separating chamber via a centrally located inlet pipe. The solids are forced outwards against the inner wall of the bowl by the centrifugal force. The scroll, which rotates with a different speed than the bowl housing, transports the solids to the conical part of the bowl. At the end of the bowl, the solids leave the bowl housing via outlet openings. Liquid is separated constantly during this process. The clarified liquid flows in the opposite direction through the cylindrical part to the drain, where it flows out freely. As with separators, specialists also differentiate between clarifying and separating decanters. In addition to clarifying, a separating decanter can also separate liquids with different specific densities. For this process, known as liquid-liquid-solid separation, the second liquid goes through another processing stage. The product to be separated enters the separating chamber through the centrally positioned inlet and is put under centrifugal force. The two liquid phases are separated in the separating zone into a light and a heavy phase. The light liquid moves in the direction of the bowl axis and flows out through the regulating tubes. The heavy liquid moves outwards towards the bowl housing and is drained off under pressure by a stationary centripetal pump. The solids which have been thrown out are transported out by the rotating centripetal pump through the conical part of the bowl to the outlet. Westphalia Separator offers no less than 2,500 different applications for separators and decanters. the drive technologies for high-performance centrifuges are as diverse as the separating technology tasks. A range of versions is available, from the belt drive through to the direct drive. The application is the most important factor. The new direct drive achieves the best results with a more rapid rotation of the separators. For achieving optimal separating results with decanters, GEA Westphalia Separator offers a range of innovative drive systems to meet all requirements and which can be adapted to the individual needs of the customer. Mastering the wide range of separating process technologies requires a wealth of experience. It requires a global presence, as well as employees who have the necessary expertise in process technology and mechanical know-how. A modern production process and worldwide quality control are also essential. GEA Westphalia Separator was one of the first companies to be certified at over 50 subsidiaries by TÜV Rheinland in accordance with DIN EN 9000. A service organization with a global network of authorized workshops ensures that our separators and decanters are integrated optimally into the production process of our customers and remain in operation 24 hours each day where necessary. Separators and decanters from GEA Westphalia Separator.